semiconductor industry to a new level. So hopefully we can leverage UCLA chips expertise in heterogeneous integration, as well as ITRI's R&D capacity to jointly develop forward-looking technology needed by the industry. So again, I'm very happy to have the opportunity to witness today's MOU signing ceremony and appreciate the strong partnership and support we have with UCLA and ITAR. So today's MOU is another first solid step moving forward. I wish a huge success in our collaboration, and thank you. Thank you again.
Thank you, Dr. Zhang. Next, I would like to invite Professor Subramanian Iyer, the director of the UCLA Center for Heterogeneous Integration and Performance Scaling, to give some words. Welcome, Professor Iyer.
Thank you so much. Dr. Peizhen Chang, Dr. Xiuhui Qiu, Nikki, Dr. Xie Wu, Robert, and Dr. Shi Che, and other distinguished guests. I am actually really honored and delighted to be here on signing this MOU with ITRI on the AI chip initiative in Taiwan. Our collaboration with ITRI is actually the centerpiece of our international collaboration in the area of heterogeneous integration and packaging for high-performance computing and artificial intelligence. We are extremely grateful for the close technical collaboration with ITRI engineers who bring incredible innovation and a wealth of experience to our collaboration. The feedback and suggestions we get from ITRI have had a very positive and meaningful impact on our research direction, our execution, and most importantly, on the education of our students who are going to lead this work in the years to come. I will also add here that many of our students are actually from Taiwan, and many of them actually go back to Taiwan. Okay, so in a way, we are giving back through our students. Our students are our biggest product. I always say that. And so I'm very happy for this collaboration. So I think this interaction, I hope, is very useful for UCLA, but I also hope it is equally beneficial to ITRI as we march along towards this new generation of AI subsystems. Thank you so much.
Thank you, Professor Iyer. Next, I'm delighted to welcome Dr. Nicky Liu, the ITAR chairman, to give some words. Welcome, Dr. Liu.
Yes, I'd like to send my greetings to all the leaders and distinguished workers and government officers in this ceremony. In representation of AI on Chip Alliance, abbreviation as AITA, I think it's very unusual day and very important time for UCLA, the best university in semiconductor, especially under Subbu Iyer, the very productive heterogeneous integration technology development research lab. In addition, I think ITRI, which I have worked for the last 30 years, and we built the technology for TSMC in 1990s. In year 2000, we started building the fabulous many good company on design, including MediaTek. And of course, my own company, Etron, Global Unichip, Ardentech, i3D, and eEver. They make a very advanced and useful products to the industry. In addition, recently, our country, under the guidance of our president, Mr. Tsai, we organized a semiconductor new research laboratory in several universities. In Tsinghua University, the leader is Dr. Berlin. Since Subu and I worked in IBM for 10 years, in the most important time, that time, for technologies, he knows Dr. Berlin, who is the expert in lithography, and later on succeeding making TSMC get the winning advantage due to his immersion lithography equipment and technology. And in the Jiao Tong University, the leader is Dr. Jack Sun, who also from IBM, and he and I and Subu working IBM research, Yorktown Heights. In National Taiwan University, the Professor Cui, whose younger brother, is working for Dr. Chen in ITRI on real AI and communication. So Subu, I'd like you to know that all your old friends and now take a leadership role to work for Taiwan on the AI on chip activities. The country identify AI as the most important item for the next decade, not only for semiconductor, but for all industry, not only for advanced industry, technology industry, but also for conventional industry. So today, I just prepared a few slides. Hopefully everybody allow me to speak very briefly what I set up the goal for myself, Yitron, hopefully for AIDA, ITRI, and the country to consider. And now I invited UCMLA to consider. That could be one of the subjects we can enhance the contents of what I point out in the slide. So my first slide, can you put my first slide?
Okay.
I just extract several slides from my recent presentation in the Device Research Conference and also the International Symposium on Semiconductor Manufacturing, and both are very prestigious conference. So Subu, I'm back to the real work on the technology in addition to the design. So I want to use the title to show you what I believe. It's a new, innovative, intelligence, power, end times civilization we are entering. That is a widespread, touching, influential technology to human beings by AI times IoT times HI times IC times semi. That's what I call pervasive intelligence era in 21st century. Next. And I believe that we are lucky to experience through the booming time of semiconductor technology in the 1990s to today. And in Taiwan, we created TSMC, which do the service of the most advanced technology to everyone in design and microsystem world. And now I believe that we, as a collaboration, UCLA with Taiwan, we can do a more. This is a revolution, a transformative from STEM to new applications. This revolution is driven by diverse and boundless smart applications, much more than we experienced in the last 50 years for integrated circuit. And it's powered by three things. One is microsystem, smart microsystem, which just like a PC to occupy certain market space in the mainframe, and later on PC become the major building block for today's huge system. And I personally believe the smart microsystem, based on what we are going to do, will generate the SuperNet, a powerful super system, allow human beings to communicate day by day, minute by minute. The second is heterogeneous integration. The third is we are entering atomic scale device and manufacturing material areas. Next one. So I think I developed this chart to illustrate it. When Subbu and I work in IBM Yorktown, that's Silicon 1.0. My mentor, Dr. Bob Denard, who is an inventor of integrated circuit DRAM, and also the scaling theory. So that's 2D scaling. And I think almost like a miracle. Human beings should stop at the 20 nanometer, but good things happen that we made vertical transistor, FinFET. And as a result, we only count the number of chips, the number of devices, transistor, on the wafers to be double every 2 years. That's still more slow. And by year 2000, I gave a talk, ISCC, I coined the heterogeneous integration of silicon-centric technology. And later on, in 2016, a milestone happened. TSMC know how to make their wafer with packaging, not the sophisticated packaging, but very effective packaging called InFO, to allow us to integrate wafer and the packaging in the wafer-based system integration. Now, I'd like to call your attention. I strongly believe we enter 4.0. The contents is not just heterogeneous integration. We want to work under the chiplet integration condition, how we define the monolithic devices, processes, and circuits, and how this new device, circuit, and process to enhance much more innovative and powerful, lower power, high speed MHI system, which I love to work with Subbu and UCLA to on the silicon plus non-silicon material to create this smart microsystem. The last one I want to show you. I hope our organization went through this booming time, much larger explosive time in semiconductor to support smart system and applications, as shown in this slide. I present this slide in year 2000 at the GSA conference. That time, the revenues of semiconductor industry is $200 billion. Another 10 years, under the prediction of Moore's Law, which is a homogeneous integration, we'll see that increase another 100 billion. So we should increase another 100 billion. That's this soil landscape, like a brown color show. So 2020, amazing. We are going to see today, 2021, we further grow another 2 digits on the revenue to 500 billion to 550 billion. That's entered this green grass area, which I even give a name for the Silicon 2.0 plus 3.0 impact, integrated system, software, circuits, and chips, ISCC, just like our conference. We always attend it every year. That belongs to what we said, heterogeneous integration. We saw many good publications from UCLA, from Subu's group, and also from ITRI, and from TSMC, and from Itron in this field. But what I just showed you, we can put the chiplets, bare die, and wafer-to-wafer scale integration with not just silicon, but non-silicon material. That's that blue cloud landscape area I draw here. I draw this chart 20 years ago. Time passed too fast. So I have no doubt that human beings, civilization entered this heterogeneous integration and the intelligence power n times field. And $1.2 trillion that Ajit Molocha of SEMI and now we invited every distinguished member, especially Subuwire, to see whether we can grow another $0.7 billion from the year 2020, which is $400 billion after human beings' effort for the last 60 years. So anyway, I appreciate everybody give me this unusual time, and I can share. It's not my assets, it's something I think can encourage all the distinguished leaders that we have I don't know how to describe, unprecedented, well, paramount, the goal. My professor, you know, Jim Midle, and recently I had conversation with Lou Terman and Bob Denard and Dr. Hua Yu. We're still owe IBM, Yorktown GAN, and now I mentioned to ITRI, they work with, you know, these people very closely. Said, hey, look, there are tremendous treasures for us to dig. So I will call Taiwan a treasure island, like the novel, use the name. And then also equally applied to UCLA. Broadcom, spin-off from UCLA, now is ranked number 6 in the revenue of the world, even bigger than TI, than ST Micro, Infineon. Amazing. So I hope through this joint venture, although alliance, that Subu can send more students, experience a year or 2 in Taiwan to develop the technology you're interested. And of course, if you have more slots, we like some students go to your place to experience in person what you instruct them. So anyway, thank you for everybody here. And thank you for MOEA, even our top Ministry of Economic Affairs come to salute and greeting all your distinguished members can start this milestone time. Thank you.
Thank you, Dr. Liu. Next, it's our privilege to have Dr. Xianyi Lin, the Science and Technology Advisor of Department of Industrial Technology, Ministry of Economic Affairs today, as the witness for this special occasion. I would like to invite Dr. Lin to give some words. Welcome, Dr. Lin.
Good morning, our honorable guests, distinguished Professor Iyer, IETA Chairman Dr. Liu, ITRI Executive Vice President Zhang, ITRI Vice President Dr. Wu. On behalf of the Department of Industry Technology, Ministry of Economic Affairs, it's my great honor to be here to witness the MOU signing ceremony between IETA, ITRI, and UCLA today. This is the milestone of the semiconductor industry R&D cooperation between Taiwan and the United States. Taiwan has a complete semiconductor industry chain and AIoT advantages, while the United States has an irreplaceable position in high performance of computing and has had a close relationship with Taiwan. By virtue of that, the importance of Taiwan-US supply chain can be seen. The development of the die-to-die interconnection common interface under IETA allows Taiwanese companies to work together to construct an AI chip ecosystem. As a result, it's much easier to link with other international corporations to evolve various AI applications. On the other hand, UCLA Chips has become an international semiconductor R&D organization on the subject of heterogeneous integration and high performance of computing under the leadership of Professor Iyer. We believe that the collaboration between IETA and UCLA leads to the future. After signing MOU with UCLA, we could lay a firm foundation for international collaboration. In this way, we can strengthen Taiwan-US semiconductor technology research and development. We will say it's a win-win situation for us to develop next generation novel AI chip products. Lastly, I sincerely wish you all a very productive collaboration. Hopefully, the COVID-19 pandemic will end soon, so everyone could return life to normal. All the best for your future success and good health. Thank you very much.
Thank you, Dr. Lin. Last, I would like to invite Dr. Zhiyi Wu, the Vice President and General Director of Electronic Optoelectronic System Research Laboratories from ITRI, to give some words. Dr. Wu, please.
Good morning and good evening, Professor Iyer in UCLA, and ITI's Chairman, Dr. Lu, and the DOIT Advisor, Dr. Lin, and the ITRI's Executive Vice President, Dr. Chang, and the ladies and gentlemen. And under the guidance of Executive Yuan and the Ministry of Economic Affairs, ITI was established 2 years ago. And with the leadership of Dr. Lu, now ITI Alliance has more than 125 members. And the ITRI collaborate with most of them. ITRI has been working on the advanced packaging technology over the years, and we developed the technology on chip-on-wafer, wafer-on-wafer bonding technology. With those technology, I think die-to-die interconnection is the most important role. And we work with ITI's Alliance. We develop a common interconnection, common interface, and we have a lot of pattern on these areas. Those technology can be used in CMOS image sensor, high resolution display, and the 5G communication. And we all know that in IoT era, there are a lot of products which has relatively small amount. Those products usually are not welcomed by those huge foundry house because the amount or the quantity is small. So ITRI also build up a pilot line which can solve this problem. So we can help the startup company or company can create more and many different products in IoT applications. And I think with the alliance between the ITA and the UCLA Chip Alliance, there are two advantages. First one, the technology developed by ITA and the ITRI with the platform of UCLA Chips, they can promote our technology. Second, we all know that UCLA Chips has a lot of latest information about the heterogeneous integration. And the system house internationally can use this platform to connect to the Taiwan's industry. Initially, ITRI can use our pilot line to verify those ideas and then forward to the foundry house for mass production. And I think with this collaboration, I think there will be a lot of fruitful results. And I thank you, all of you, to coming to this ceremony. And I wish all the best, the good health, and the great success. Thank you so much. Thank you.
Thank you, Dr. Wu. Yes,
Can I
Dr.
say
Chang,
a
would you like
few
to
words?
say some words? Yes. Please.
Actually, I'm really happy to to see Nicky Lu's expression, the successful secret of success, the equation, the formula with so many I's. But I propose that I propose to add 2 more I's to your formula of success. One is iron, another one is E3. Both start with I, okay? Next time when you present your transparency, please add I and E3 on top of the equation, all right? Thank
Okay.
you.
Very nice. Thank you.
Okay, thank you.
Hey,
Now,
by the way, Subu, you know the Dr. Ho Ming Tong,
Yeah,
Tong, who
from
used
RPI.
ASE to grow ASE significantly. In the last 5 years, he and I work on power IC assembly and testing.
Oh, okay.
And
Yeah,
now he and I started a very small venture, 2 of
Oh,
us.
okay.
Yeah, we call heterogeneous integration technology semiconductor consulting firm. We have several projects on doing IoT modules for 5G and the very advanced Wi-Fi system.
Oh, wonderful.
We don't work as hard as, go to grab 100 people. But we instructed several companies in doing the work that we believe it's belong to what the landscape I show you. So anyway,
Yeah,
Dr.
no,
and
I think
Dr.
that's fantastic.
I want to add another heavyweight guy, Subu No. He's the guy who really understanding the technology in packaging and IoT. He really built up a lot of for ASE, Taiwan's largest and the world's largest assembly house. Yeah, so I want him to join, but today his wife has something. So he say hello to everyone if I can have opportunity. So anyway, I want to bring him to see Dr. Wu and probably Dr. Chen at the right time. Okay, thank you.
Thank you.
Thank you.
now we have come to the main part, the reason we are here for, the MOU signing ceremony. The signee representing UCLA is Professor Subramanian Iyer, the director of the UCLA CHIPS. And representing E3 is Dr. Zhiyi Wu, the Vice President and General Director of Electronic Optoelectronic System Research Laboratories. And the MOU is to be witnessed by Dr. Xianyi Lin, the Science and Technology Advisor of Department of Industrial Technology, Ministry of Economic Affairs today. Now, I'd like to request Professor Iyer and Dr. Wu both to sign the MOU between E3, ITA, and the UCLA CHIPS. Dr. Wu, please remain seated. Professor Iyer and Dr. Wu, please hold the signed agreement to take a photo with all the online distinguished guests, including Dr. Peiren Zhang, Dr. Xianyi Lin, and Dr. Nicky Lu. Professor Iyer, you might need to move your camera a bit far. Please sit down. You can sit down and take a photo together with us. Yes, and then have a camera zoom in with only the agreement and yourself. No, also with Professor Iyer. Yes, a bit far, so you won't cut Professor Iyer's head. A bit. Zoom out. Yes, perfect. A bit. Zoom out a little bit. Yes, up. Perfect. Okay, you move. Could you zoom out a little bit? Move up. Yes, great. Is that okay for a photographer? Okay, you may place down your MOU agreement now. I'd like to request Dr. Wu and all the online distinguished guests, including Dr. Peiren Zhang and Dr. Xianyi Lin and Dr. Nicky Lu, all take a photo together and post thumbs up for this photo. Thumbs up, yes. And look in the camera. The signing of MOU today, we hope to utilize Taiwan's AIoT advantage and experience of the U.S. high-performance computing to jointly strengthen and forge complementary step of our semiconductor technology and research and development. Okay, next group photo. Dr. Wu, please remain unseated. Now, I'd like to invite Dr. Shijie Zhang and Dr. Weizhong Luo to come up on stage for a group photo together. Once again, I'd like to request all the participants, including on-site and online, Dr. Pei-Ren Zhang, Dr. Xianyi Lin, and Dr. Nikki Lu, all post the thumbs up for this photo. Okay, thumbs up. Okay, and look into the camera, smile. Big smile. The signing of the MOU today, we also expect to add depth to cooperation between Taiwan and the U.S. in supply chains, while also successfully launching new business opportunity for AI chips. Okay, Dr. Wu, Dr. Zhang, and Dr. Luo, would you wear the mask so we can all take a photo together? The online distinguished, please wait a second. We will take one more photo with a mask on site. Yes. Okay. So one more thumbs up photo and big smile, even though I can't see you under the mask. Thank you for everyone's participation. We wish to extend our sincerest appreciation as well as our best wishes for the good health and well-being of all the distinguished guests joined us this morning. This concludes our ceremony today. And Dr. would like to have some words.
Hi, Nikki, thank you so much. Professor
Nikki,
Iyer, thank you.
Don't forget
and
to
hope to
add
see you again.
Iyer and the E-Tree to your equation, all right?
Yes, more I.
Yeah, right. Two more eyes. Yeah.
Iron is important.
Yeah. Right. Okay, thank you.
Thank you so much.
Thank you, Dr. Lin.
Wonderful.
Great event. Yeah.
Great.
Yeah. So now we have to get to work.
Yes.
All right. So thank you and
Okay,
goodbye.
see you then.
Thank you so much again. Okay, and what should we do?
张副，谢谢。
好，谢谢，好，谢谢，好，谢谢，
Thank you.
好，谢谢，Thank you。
Bye.